we have been looking at the problem of finding the shortest subarray that adds up to a given sum in list of positive numbers. We have looked at it in a lot of detail. Before wrapping this up, let's look at some example problems. These problems have been taken from, let's say, different sources. I thought it's quite interesting to look at them because that connects the dots for us, right? So basically, this problem called buying plots. Now, this is from the practice material that's available online for ZCO, the Indian, Zonal Computing Olympiad. Look at this problem. It says along one side of a road, there's a sequence of vacant plots of land. Each plot has a different area, non-zero. So clearly area has to be positive. So area forms a sequence A1, A2 until AN. So kind of like a list of numbers. You want to buy K acres of land to build a house. You want to find a segment of contiguous plots. Notice the moment you see contiguous, your mind should race in the direction of a sliding window because we are looking at subarrays, right? So segment of contiguous plots, that is a subsection in the sequence of minimum length whose sum is exactly k. Now think about it. This is exactly the same problem. What we have to do is to find the minimum length sequence from this sequence, minimum subarray of this from this list, which will add up to the target, which is exactly k. Exactly the same problem. Let's look at one more. We have this one from the US, ACO. It's probably a practice problem, or maybe it's available from the contest as well, right? Again, this is available online. It's called books. So it talks about this person, Valera, has got some free time, goes to library, reads some book. Today he has T minutes to read. So my target is T here. He picks up N books, and each book he knows how long it will take to read. So basically, AI minutes to read, let's say the ith book. Now, the task here is choose an arbitrary book I, read books one by one, so that, for example, I plus 1, I plus 2, and so on and so forth. So kind of like a contiguous window subarray continues the process until either runs out of time or finishes the nth book, which means either I reach the end of the list or I, let's say, reach the target. Remember, target is T, right? Reads each book in the end, so it doesn't start the book, and basically doesn't have enough time to, let's say, finish it, right? And at the same time doesn't leave the book unfilled, let's say, unread, right? So print the maximum number of books whether I can read. Well, think about it. This is exactly same problem, but in a slight twist. Basically what we are seeing is the largest, because maximum here, right? The largest sub array that adds up to this target T. Pretty much that is the problem we are looking at. Once again, very closely related to what we have been seeing. In fact, this brings me to some variations. We just saw this longest window, which is less than a threshold, smallest contiguous array whose sum is greater than a certain threshold, count the number of subarrays with sum, let's say, less than or equal to t. So several variations of this, but you can see that, all of this, a sliding window will be helpful because rather than computing all the subarrays of different size, this provides a much neater implementation, right? So very useful, very interesting in several problems, but obviously it requires practice and there's nitty-gritty detail to be worried about, as we saw while we built our solution. But anyway, very interesting. Do look at our website www.whitebyte.in for more such content and enjoy programming. Take care. Thank you so much. Bye bye.